told... Welcome to Copilot Podcasts. What if I told you that the future of sustainable architecture and fashion is growing right beneath our feet? Today, we're exploring how mushrooms are revolutionizing everything from building materials to high fashion. By the end of this episode, you'll understand why fungi might be the key to a more sustainable future.
And it's absolutely fascinating how these fungal materials are already being used in real-world applications. We're talking about buildings, furniture, and even luxury fashion items.
So, let's start with the basics. What exactly are we talking about when we say mushroom materials?
Well, we're specifically talking about mycelium. That's the root structure of mushrooms. According to research, these microscopic threads can be grown into almost any shape and create materials with remarkable properties.
Wait, so you're saying we can basically grow building materials?
Exactly. And here's what's incredible. These materials have a thermal conductivity of just 0.03 to 0.08 watts per meter Kelvin, making them excellent insulators.
Could you break down what that means for our listeners?
Sure. It means these materials insulate as well as, or better, than traditional materials like fiberglass or foam insulation, and they do it while being completely natural and biodegradable.
That's incredible. And I've heard they're being used in fashion too?
Yes, companies like MycoWorks are creating leather alternatives from mycelium that are being used by luxury brands like Givenchy. It's remarkably similar to animal leather, but completely cruelty-free.
You know, it reminds me of that scene in Austin Powers where he asks for $1 million as if it's this huge sum.
Oh yeah, how does that connect?
Well, just like how that sum seems small today, I think our current building materials will seem primitive once mushroom materials become mainstream.
That's an interesting perspective. And speaking of traditional materials, there's actually a fascinating connection between mycelium leather and traditional Japanese craftsmanship.
Really? Tell me more about that.
Well, the precision and patience required in growing mycelium materials mirrors traditional Japanese attention to detail and respect for natural processes.
Let's talk about the practical applications. What kind of buildings are actually using these materials?
There have been several notable projects. The Hi-Fi Tower in New York in 2014 was built using mycelium bricks, and the Growing Pavilion in the Netherlands in 2019 showcased the material's potential.
And how do these structures hold up?
According to testing, mycelium materials can achieve compression strengths of up to 2.9 MPa when reinforced. While that's lower than concrete, it's perfect for non-load-bearing applications.
What about durability? I imagine moisture could be an issue.
That's actually one of the current challenges. These materials can absorb up to 200% of their weight in water, so they need proper treatment for outdoor use.
But for indoor applications, that's not as much of an issue, right?
Exactly. For interior walls, furniture, and decorative panels, they're already proving to be excellent alternatives. Companies like Mogu are creating beautiful acoustic panels with great sound absorption properties.
Let's talk about the environmental impact. How do these materials compare to traditional options?
The environmental benefits are remarkable. These materials are not only biodegradable, but also help reduce waste by using agricultural byproducts as growing medium.
So we're basically turning waste into useful materials?
Exactly. Things like sawdust, rice hulls, and coffee grounds can all be used as substrate. It's a perfect example of circular economy in action.
That's fascinating. What about the manufacturing process? How complex is it?
The basic process takes about 7-30 days, depending on the application. The mycelium is grown in molds with the organic substrate, then dried to stop growth.
That seems relatively straightforward.
Yes, but maintaining sterile conditions and consistent quality at scale can be challenging. That's one of the current limitations of the technology.
What about cost? How do these materials compare price-wise?
Currently, they're often more expensive than traditional materials due to the small scale of production. But as technology improves and production scales up, costs are expected to decrease.
You mentioned fashion earlier. How are designers responding to these new materials?
The response has been incredibly positive. Stella McCartney and other major fashion houses are already using mycelium leather in their collections.
And consumers? Are they accepting these fungal alternatives?
Surprisingly well. The quality has become so good that many can't tell the difference between mycelium leather and animal leather.
That's really encouraging. What other applications are being explored?
Packaging is a big one. Companies like Ecovative are creating mycelium foam that could replace styrofoam in packaging applications.
And this packaging is fully biodegradable?
Yes, it can completely break down in about 45 days under proper conditions. Compare that to hundreds of years for traditional plastic packaging.
The potential environmental impact of that is huge.
Absolutely. And what's really exciting is that we're just scratching the surface of what's possible with these materials.
What are some of the most innovative applications you've seen?
One fascinating project is MycoTree, which uses mycelium blocks in combination with bamboo to create load-bearing structures through clever geometric design.
So it's not just about the material itself, but how we use it?
Exactly. It's about working with the material's properties rather than trying to force it to behave like traditional materials.
What about fire resistance? That's crucial for building materials.
These materials actually perform quite well in fire tests. They have low heat release rates and can even self-extinguish.
That's impressive. Are there any other surprising properties?
Yes, they're excellent sound absorbers. The natural structure of mycelium creates a material that can effectively dampen noise.
So they could be used in recording studios or concert halls?
Absolutely. Some companies are already developing acoustic panels specifically for these applications.
What about the future? Where do you see this technology heading?
I think we'll see much wider adoption in construction and fashion within the next 5-10 years. The market is projected to grow significantly.
Any particular areas you're most excited about?
I'm particularly excited about the potential in developing countries. These materials could provide affordable, sustainable building materials while addressing waste management issues.
That's a really important point about accessibility.
Yes, and the technology is relatively simple. Any community with agricultural waste could potentially produce these materials.
What do you think is the biggest challenge moving forward?
Scaling up production while maintaining consistent quality is probably the biggest challenge. We also need better standardization and testing protocols.
But it sounds like the benefits could far outweigh these challenges.
Absolutely. The potential to create truly sustainable, biodegradable materials that perform as well as or better than traditional options is revolutionary.
As we wrap up, what's the one thing you want our listeners to remember about mycelium materials?
That nature has already solved many of our material challenges. We just need to learn how to work with it rather than against it.
That's a powerful message. And on that note, thanks for joining us on Copilot Podcasts. Remember, the future of sustainable materials might be growing right under our feet.